everybody, Duck here. Did you ever take a coin and have somebody flip it and say heads or tails, and then you take a guess, heads or tails? Looks like we got tails here on this coin. The heads is always the side that has the head on it, and the tails is the other side, which could have a number of things on it. So anyway, that's how you do heads or tails. Today I'm going to introduce you to probability. And as we talked before, I don't like to do things unless I know I'm going to need them. So probability has a lot to do with chance. So what are the chances that this will happen? Or what are the chances that that will happen? That's something that happens all the time in our life. So let's write down the word first. Probability. Pretty long word. Probability. So we have ability here. So what are the chances that something will happen? So first of all, let's take this simple coin. This simple coin has how many different sides? The outcome of flipping a coin will either be heads or, as we call it, tails. Heads or tails. So I either have a chance of doing heads or tails. There are two possible outcomes. Two different sides. Or two different outcomes. So when we talk about probability, we want to know what are the chances that this will happen, or what are the chances that that will happen. Well, when we look at this, we know that we're either going to get heads or tails. So just like all fractions, we would need to know the total number of outcomes, which we said are 2. I might get heads. That would be 1 out of 2 chances. And I might get tails. And that's also 1 out of 2 chances. Now, something that you're going to notice about probability is that when you take a look at your outcomes and the probability of it becoming heads is 1/2 and the probability of it becoming tails is 1/2, when you add all of your probabilities together for your total outcomes, you will always get the number 1. So if I take 1/2 plus 1/2, I get 2 halves, which does equal 1. Okay? Now, if I were to take this and tell you to guess whether or not you're going to get heads or tails, it would be hard to guess, not too hard because there's only 2 possible outcomes, but it would be hard for you to predict upon shadow of a doubt which side would be which. So if I flipped it one time and I said heads or tails, you would have a 1/2 probability if you said heads, or a 1/2 probability if you said tails. They also talk about this in percentages also. So 1/2 is 50% chance. 1/2 is 50% chance. So you have a 50% chance of guessing heads or guessing tails. Now, if I said to you, do it 3 or 4 times, and then tell me how many times you would get heads or how many times you would get tails, you could probably write down, well, I could get heads, heads, and heads. I could get heads, heads, and tails. I could get heads, tails, and tails. But if I told you, do it 1,000,000 times, doing it 1,000,000 times is really not hardly possible. Not that somebody could never do it, but I would doubt that somebody would be able to sit and do it 1,000,000 times. What we found out though is if you did it a million times, you would get really close to finding out that half of the time you would get heads and the other half the time you would get tails. And what we call there is actually randomness. So randomness is that, excuse me, if I do it one time, you can't really guess for sure whether it's going to be heads or tails. But if you did it a million times and wrote down whether you got heads or tails for those millions of times, you would end up getting half the time heads and half the time tails. Okay? So, again, before we get too deep into other parts of probability, I just want to again review that when we have probability, we need to know what the chances are that these things would happen. Here with a coin, my chances are heads or tails. So I have two different outcomes. The possibility of me getting heads would be 1 out of the 2 outcomes. The possibility of me getting tails would also be 1 out of 2 of the outcomes. Not so bad, right? Well, let's try it with some dice. I happen to have some different dice here. The one that usually people are used to looking at would be your 6-sided die. Okay, so I have a 6-sided die. I'm going to move the other 2 aside for now. Obviously, on a 6-sided die, I have 6 sides. And on this 6-sided die, they're actually marked 1, 2, 3, 4, 5, and 6. Okay? So, I have a 6-sided die. I'm either going to get a 1, a 2, a 3, a 4, a 5, or a 6. Okay? 1, 2, 3, 4, 5, or 6. Now, what are the chances or what are the probabilities that when I roll this, I will get a 1, 2, 3, 4, 5, or 6? Well, let's take a look at that. So if I have a 6-sided die, I have 6 possibilities. These are my 6 possibilities. And just as before, for my outcomes for here are 1, 2, 3, 4, 5, 6. All of the possible things that could happen if I take a 6-sided die and roll it. Okay? Now, if I look at each one of these separately, what is the probability, and again, we're talking about probability, another way to say, what are the chances, what is the probability or what is the chance that I would get 1 out of 6? Well, I have 6 sides, so the probability of me getting a 1 would be 1/6. The probability of me getting a 2, there's only 1 2 on here. So the probability of getting a 2 would also be 1/6. How many 3s do I have on this die? When I look at this die, I only have 1 3. So the probability of me getting a 3 is also 1/6. The probability of me getting a 4, there's only 1 4 on this die. So 1/6. So as you can guess, it's 1/6 for all of these because there are 6 sides. So the probability of me getting these would be 1/6 for each one. Now, do you remember what I said when we looked at the coin? If I add the probabilities of all my possibilities, what will I get? Put your answer in the chat. What will I get if I add all of the probabilities together? Okay, hopefully you looked at adding all these fractions and they all have the same denominator. So when I add 1, 2, 3, 4, 5, 6, I will get a total of 6 out of 6, which is 1. And that's what we want. Anytime we have all of our possibilities, when we add them together, we should always get 1. That way we know we have 100%. The probability of 1 or 100% of the possibilities. Okay, let's look at this a little more. I'm going to erase this here. And just at the top, I'm going to remind you that on this 6-sided die, I have 1, 2, 3, 4, 5, 6. And underneath, I'm going to put the probability of getting each one of those. This is called a probability model or probability table. Okay, so there are my sides and there are my possibilities. Now, what if I asked you, what's the probability of getting a 2 or a 5? What is the probability of getting a 2 or a 5? Well, the probability of getting a 2 is 1/6. The probability of getting a 5 is also 1/6. So the probability that I would get a 2 or a 5 if I rolled the die would be 2/6. And hopefully you see that that will reduce. So that reduces to 1/3. So the probability of me getting a 2 or a 5 is a 1/3 chance. Now, if it's a 1/3 chance, can any of you tell me what percent that is? It's a little bit tricky. If it's a 1/3 chance, what percent would that be? Put your answer in the chat. If you're not sure, you can divide 1 divided by 3. You can either do it in your phones or do it in a calculator. Take 1 divided by 3 and you'll find out you'll get 0.333 and it'll go on forever. So since we're talking about percent, we only want to look at the first couple numbers after the decimal. So it's actually going to be 33% chance. So I have a 33% chance of getting a 2 or a 5 when I roll this. So let's take a look at this and see. I happened to get a 2. I had a 33% chance of getting a 2, and I did get a 2. So there we go. So those worked out for me well. But as you can see, I wouldn't want to put a whole lot of stock on getting a 2 or a 5 because I only have a 33% chance of getting it right. My chances are even less if I just look at what's the probability. I'm going to go ahead and erase this here. What's the probability of just getting a 4? What's my probability of getting the 4? Okay, so if I take my probability of getting a 4, I'm going to take 1 divided by 6. 1 divided by 6. Now, you can put that in your calculator. You would put in 1 divided by 6. Or, for those of us that have to practice our long division, you would do it this way. So here we would take this and add a decimal point. 6 will go into 10 one time. Then I need to add some zeros. And it's okay if you don't remember everything on how to do this right away. I just want to show you how we would figure this out by hand. I'm going to get 36 here, and then I find out when I subtract I'm going to get 4 again. So that means that this is going to repeat on and on and on. And I'm going to get 6, 6, 6 going clear across. So again, since I'm looking at percentages, right now, I only want to look at 2 places past the decimal. So I'm going to have about 16% chance. Only about 16% chance. Some people might round this since the 6 is bigger than a 5 and say 17% chance. But either way, whether it's a 16% chance or a 17% chance, I wouldn't want to put a whole lot of stock into getting the right answer when I only have 16 or 17% chance of getting my answer right. Let's see. Probability of getting a 4. Let me roll and see if I can actually get it. I got a 5. So, not surprised I didn't get it right since I only had a 16% chance. Okay, let's move on to something that isn't as common. I have some other die here too. And this time I'm going to be asking you for help. So get ready to put your answer in the chat. Here I have kind of a different die. This one has 4 on the top and 4 on the bottom. So it's 8-sided. I have an 8-sided die. So in that case, I want to check and see what numbers are on here. And I took a look at it and I have the numbers 1 through 8. One through 8. Okay, so here we have our possibilities. Our possibilities or our outcomes can be 1 through 8. So now let's take a look at what our probability would be. Since I have 8 possible outcomes, each one of these would only have a 1/8 chance of getting picked. 1/8 chance. What percent is 1/8? Well, 1/2 was 50%. 1/3 was 33%. 1/8, I can guess, is probably even smaller. So if I take my 1 and I divide it by 8 real quick so we can see, I have to add my decimal point and a 0. I can see that when I take a look at what percent I would get, this one actually will end once I take it 3 times. I bring my decimal up. You can see that's 12.5% when I change my decimal to percent. So 12.5%. Okay? So I only have a 12.5% chance of getting this correct when I guess. So let's take a look at the possibilities again. I have 1, 2, 3, 4, 5, 6, 7, 8. And each one of these is 1/8 chance of getting selected. Now, I already said that if I were just to pick one of them and said, what's the probability, let's say getting a 3. What's the probability of getting a 3? I only have 12.5% chance of getting it right. Remember? Because each one of these is 12.5%, 12.5% chance. Okay? Let's go ahead and see if I can get a 3. I did. I happened to get my 3. So 12.5% chance. I did in fact get a 3 this time. So that was pretty lucky. I wouldn't want to try that often, or definitely wouldn't want to bet on it, because 12.5% chance is not so good. Now, let's try another thing. What's the probability of getting an even number? An even number. Do you know what an even number is? Put in the chat if you know what an even number is. Give me an example of even numbers. Tell me what numbers up here are even. Put that in the chat. Well, hopefully you put 2, 4, 6, or 8. 2, 4, 6, or 8 are called even numbers. They're all divisible by 2. So if I were to take a guess at what the probability was that I would get an even number, I would say I'm going to have 1/8 plus 1/8 plus 1/8 plus 1/8, because there are 4 possibilities that I have, and each of those possibilities are 1/8. So if I add 1/8 plus 1/8 plus 1/8 plus 1/8, luckily we have the same denominator. It's all 8, so I can just add the numerator, which is on the top, and I will get 4 out of 8, which is 1/2. So I have a probability of 1/2 of guessing an even number. Do you remember what the percent is if the probability is 1/2? Put the answer in the chat. Hopefully you remembered from when we did the coin that the probability of 1/2 is a 50% chance. 50% chance. Okay? So, let's see if I will get an even number this time when I roll my die. I got a 3. So that time I wasn't so lucky. Even though I had a higher percentage or higher probability of getting it right, I still had 50% chance of getting it wrong. Okay? All right. So now let's do one more. And again, I'm going to be asking you this time to help give me some answers. I have this really cool die. This one's my favorite one. This one has 5 on the top and 5 on the bottom. Interesting, huh? So here I want to find out what the probability is when I roll this. The one that's on top is the one that's flat. So we'll make sure we understand that, okay? The one that's on top is the one that's flat. Here I have 1 through 10, and I'm going to go ahead and put the numbers at the top. And I did check to see what the numbers were. Actually, no, a 10's not on there, it's 0. So we'll say 0 through 9. Sorry about that. Should have checked that first. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 different possibilities. 10 possibilities. Those possibilities are 0 through 9. Okay? Now, I want you to tell me, what would the probability be of getting each one of these if they're all equally likely to be chosen if I roll that die? So what's my probability? Put it in the chat. You can say out of, if you want to say 5 out of 7, or you could write it as a fraction by using the slash on your keyboard. It's up to you. Well, hopefully you remembered, since we have 10 possibilities, the probability of each one of these would just be 1/10. Now, let's do a couple problems. Can you tell me what the probability would be of getting a 3 or an 8? A 3 or an 8. Give it to me as a fraction. I guess we should have said what the percentage of 1/10 would be. Can somebody in the chat tell me what the percent of 1/10 is? What's the percent of 1/10? You can either take 1 divided by 10 in your calculator or phone, or you can take 1 divided by 10 using long division like we did before. 1/10 is in fact 10%. So we have a 10% chance for each one of these. Now, I asked you, what's the probability of getting a 3 or an 8? So first I want you to give me the fraction. What's the probability of getting a 3 or an 8? Put that in the chat. Let's see. The probability of getting a 3 is 1/10. The probability of getting an 8 is also 1/10. So if I add those together, I will have 2/10, which does reduce to 1/5. Oops, sorry, 1/5. Now, that was adding the probabilities. What if I said, what is the percentage? Well, if I have 10% plus 10%, I'm going to have 20%. And hopefully you looked at this and saw, well, 1/5, 1 divided by 5 is also 20%. And you can put that in your calculator if you like, or phone, or you can do it by long division and you will see you get 20%. So I have the probability of 1/5 of getting a 3 or an 8. Let's roll and see what happens. I got a 2. So the 2, I lost out. I only had a 20% chance. Wasn't very good odds. So that time, I definitely didn't get the right answer. Now, let's do one more. I want you to tell me, what's the probability of getting a 0, a 4, or a 7? A 0, a 4, or a 7. Put your answer in the chat as a fraction first, and then put it as a percentage. So you can give me both. Give me the fraction, and then give me the percentage. Okay, so we know we have 1/10 plus 1/10 plus 1/10. That would be 3/10. 3/10 doesn't reduce. And 10% plus 10% plus 10% would be 30% if I put it as a percentage. So hopefully you got that correct. One more for attendance. And if you don't know the answer, you can just put IDK for I don't know. But I really want you to try. So for your attendance question today, I'm going to ask you this. What is the probability of getting an odd number with this 10-sided die? What's the probability of getting an odd number? See if you can give that to me as a fraction and as a percent. And that's how I'm going to take your attendance today. Okay, as a fraction and a percent. If you're not sure what odd is, odd means 1, 3, 5, 7, or 9. 1, 3, 5, 7, or 9. Those would be your odd numbers. Okay, good luck. So I'll be looking forward to seeing your answer in the chat, and hopefully I'll see you again next time. This is Doc. Peace.